Hello everyone and welcome back to another video. Today we'll be continuing with our series of going over how exactly to make a chess engine within Python. So in this particular video we will be going over the legal moves side of things. So we've already covered the first two main modules, the foundation functions, as well as this display and interface. Now this legal moves is pretty much like the heart of our chess engine, so we'll spread this across several different videos. But on this particular video, I want to go over the return of the possible moves. So it's basically the top function within the legal moves function within our entire chessbot. So let's basically explore what exactly this means first. So in any particular situation, let's say after we play this move, we have several different moves which we can play. So we have all of these different possible pawn moves which we can do. We can move the knights from here to here or here to here. We can move the bishop from anywhere across this line, the queen from anywhere across this line. We can even move the king up here, doing a little bomb cloud if you like. So those basically are all the possible different moves which we can do in this particular position as white. So if we want to basically come up with some sort of function which returns the possible moves of a particular coordinate within the grid. So for example, let's say we were to pick this particular queen here. So this function just determines which squares the queen can go. So in this particular situation, the queen could go into any one of these four squares. However, what the queen cannot do is go in any of the squares here, or here, or here. Now, the reason why is because it's being blocked off by different pieces across all of these different angles, and that's basically what we will be exploring in the return of the possible moves in this particular video. So now let's go to the functions. So if you're following along on GitHub, as I would recommend you do, this is basically on line 191 over here. And this is basically the mammoth function which we have and which we will explore now. So let's start line by line. So we basically have all of these different possible piece numbers which we have. We have pretty much, if the piece number is 1, then that's basically a pawn. If the piece number is 2, then that's a knight. Otherwise, this bit of code does all the other pieces. So the reason why we split this into 3 different sections is because the knight moves and the pawn moves, those are like quite distinct from how king moves or queen moves. Since if you think about it, like a queen and king, their moves are actually very similar. Since a queen and king can move in any other direction, but the king can only move one square in any direction. The queen can move like any number of squares in any direction. And then if you think about how rook and bishop moves, they're also very similar. A rook can move any direction, but horizontally and vertically. Bishop can move any direction, but diagonally. So all 4 of those pieces are quite interlinked. So we can determine the legal moves of all 4 of those pieces using this one function over here. But then if you think about how a pawn moves, it's rather strange since it's different for white or black. It's the only piece where basically the color actually matters in determining what move you can play with them. And it doesn't even have like a set like sequence which you can follow. So for example, it can move 2 squares on the first move, but otherwise it can only move 1. It can do things like en passant, which is like it shouldn't even be a rule, but it is. And obviously capturing with pawns is obviously different to how moving a pawn regularly is. And then a knight is obviously like also not similar to any other piece which we have on the board, since it doesn't move in a straight line basically. Like it cuts through certain coordinates, moves in an L shape. So which is why we had these 3 blocks which determine which of the how the piece will actually move. So before we jump into that, just a bit of quick stuff here. This just determines the piece number. We end it with 7, since from the first 3 bits basically represent the piece number, and the 4th bit represents the color. So we end it with 8 to determine the color, and it with 7 to determine the piece number. Okay. So if the piece number is 0, then that's basically not a valid piece. So we just return like an empty array. That's it shouldn't, like we ideally shouldn't have to return the possible moves of a piece which doesn't exist, but in case it happens, we return an empty array. Now, if the piece number is basically 1, then what we do is we have all of these different conditions. So remember, piece number 1 basically corresponds to it being a pawn. So if the color is 0, then it has this particular moving vector and these particular capturing vectors. And otherwise, if the color is 1, i.e. it's white, then it has these moving vectors and these capturing vectors. So let's just go to what exactly these capturing and moving vectors represent. So if you go over here, then the vectors, these are basically all the different vectors. And now if you go back over here, then we know that the moving vector, if the color is 0. So what this corresponds to is, consider this black pawn. So this black pawn can move across this vector over here. Now this vector is basically 1, 0, which is that particular vector which we have represented. And now the pawn captures like this and like this. So these two capture vectors are 1, -1 and 1, 1. So those would be the moving vectors and capturing vectors for the black pawn. Now for the white pawn, it would basically be the reverse. So its moving vectors would be from here to here, which is 0, -1, oh, sorry, -1, 0. And its capturing vectors are -1, 1 and -1, -1. So those are the different capturing moving vectors. And what we basically do is we determine if the coordinates are, so this particular bit of code basically just determines whether there's a piece in front of the pawn, since we can only move the pawn if the piece in front of it, if there's no piece in front of it. So if the first coordinate is 1 and the second coordinate is 0, or if the second coordinate is like, if the row is 6 and its color is white, is white, sorry. So this basically determines if it's the first move of the pawn, and what that will do is it will basically mean that the pawn is eligible to move 2 squares forward. So basically what we have is a result equals the vector addition of the coordinates as well as the moving vector. And then if the result, if that particular result is free on the board, then we can indeed move there. And then we append this to the moving array. And then and now one more thing is the pawn's the only piece which has a different moving and capturing sequence. So this is for the moving sequence, but then we also have a rule for the capturing sequence. So with the capturing sequence, we basically need to determine whether that particular piece is of the opposite color. So for vector and capturing, we determine whether its color is opposite if its color is not equal to the original color. Okay? So that's how we do the capturing sequence, and that's how we do the moving sequence. And now, if you notice, we have these list comprehensions for both moving and capturing. So the reason for this is we basically just ensure that all the moving and capturing vectors are indeed on the 8x8 grid. So we just do if the moving and capturing follow the 7x7 pattern. And then finally we have for moving capturing and for moving moving, we basically append it to the possible moves of that particular piece, which in this case is the pawn. So that's basically how the pawn works. And now if we go of how the knight works. So how the knight works is we basically have n1 and n2. So n1 and n2 are the different horizontal and vertical offsets. So if you think about it, a knight can basically, let's go back to the actual chessboard. If we were to just move the knight here, and then we'll just wait for black to play a move, and then we'll move the knight to a central square. So if we basically consider this knight, this knight can either go here, 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 or here. So anywhere which is basically in an L shape from that particular square. So another way you can think about this is any square which the knight can move, it's basically it's either ±2, ±1. Its vector to each of these squares is ±2, ±1 in either order. So for example, this square it would be it goes one column, it goes up 2 column, 2 rows, sorry. So -2, and then it goes left column, so it's -1. So this is -2, -1, this is -2, +1. Then this would be like +1, -2, +1, -1, +2, etc., etc. So if we go back to the code, then this is basically, sorry, here we are. So we basically go for n1 in -1 to 1, and n2 in -2 to 2. And now positions is basically the vector addition of coordinates and n1 and n2. So what this does is this goes -1 and then -2. This is how it iterates: -1, -2, then -1, 2, then 1, -2, then 1, 2. So that's basically how we go. And then we basically perform the vector addition between the current coordinates as well as n1 and n2. So n1 and n2, that tuple is basically the combination of -1 and -2. And then we go the vector addition of n2 and n1. So we do this in both directions. Since remember, the knight can move either -1, -2, or we can do the other way around, -2, -1. That's also valid. And then for each of these positions, there's one very important thing which we need to determine. We need to first see if it's within the actual board, so if its limits are within the 8x8 grid. And then we also need to determine whether the position it's moving to is not the color, it's not the same color as the piece. And then another thing, so it's not the same color as the piece, which basically translates to either it's an opposing color or the piece is empty, okay? So that's basically it. If these two conditions are met, then we basically append it to the possible array. So that's basically the knight moves. And now if you're wondering what this possible array does, basically just that's the final array which will return, regardless of which piece number it is. Okay, and now we go to the big boy. So this one's basically the vectors for all the other pieces apart from knights and pawns. Okay, so to consider how these work. So if we basically, if we move the bishop here, let's say. So if we consider what the legal moves for this particular bishop are, then the bishop can basically go anywhere in this particular diagonal. It can go anywhere in this diagonal, or it can go anywhere across this diagonal, okay? So if you think about it, then all of these diagonals are basically just vectors. So this particular vector would be going up a row and going right to column. And then this one would be going left to column and up a row. And then like all of these would be like 1, -1, 1, 1, -1, 1, and -1, -1. So all of those are the different vectors which that bishop can go across. And then if you think about the moves for a queen, the moves for a queen and moves for a rook and moves for a king, they're all very similar, since all of them are just vectors in different directions. And apart from a king, all the other pieces can go like as far as they want in that particular direction until they meet a roadblock. And we'll come on to exactly what a roadblock corresponds to in code. But let's just think about what a roadblock means intuitively. So a roadblock can either be the end of the piece and the end of like the grid. So in this case, the bishop can't extend any further across this vector since it's the end of the board. Or it could mean the end, it could mean encountering another piece. So in this case, it encounters this particular piece. Or it could mean encountering a piece of the same color or the different color. So the bishop moving from here to, let's say, this square wouldn't be valid since it would be jumping across these two squares. And therefore, that's how we would determine the roadblocks of the bishop. And now for a rook, it's exactly the same, except the fundamental unit vectors, which you can travel across, instead of being diagonal ones like the bishop is, the ones for a rook are basically horizontal and vertical. And then for a queen, it would basically be horizontal and vertical and diagonal, all of them. And for a king, it would be the same as a queen, except the scale of those vectors would basically just be 1. It wouldn't be able to extend infinitely like all the other pieces do. So now let's just have a quick look at the actual code. So we basically, while not done, so while we're still in this loop, what we do is the new coordinates is the vector addition of the original coordinates, the direction is the unit vector in a particular direction, as well as the scale. So, and the scale we basically increment it every time we iterate. And then we continue doing this. All of these moves are legal until we encounter a roadblock. So one roadblock, this is basically one roadblock. We've reached the end of the grid, or we've reached a piece which is a different color, or the same color. All of those are roadblocks. And then we basically append this particular new vector into the possible array, and then we increment the scale, and then we just repeat this again and again. And now we have this particular line. So if the piece number is 6, i.e. if it's a king, then we basically set done to equal true the first time we iterate over, since the king can only move in one vector in each of the directions. And now, now one more condition which results in that particular vector being finished is if the piece is a different color. So remember, if the piece wasn't, if the piece was the same color, then that move isn't even valid. But if the piece is of a different color, then the piece can move to that particular square, except it can't move any further in that direction. So then we set done to equal true. And now after done is equal to true, then we basically just exit. And then all of these done equal true basically just ensure that we exit out of this done loop. And then we would have appended all the possible arrays, all the possible vectors to this possible array. And then we finally just finish off by returning the possible array. And this possible array just returns all possible moves. And then we have another huge job, which we'll go over in the next video. But a quick intro to what exactly that will be is that it's not good enough just determining which vectors we can actually transition from for a particular piece if the move isn't legal. And what would constitute a legal move versus a non-legal move? It would basically determine whether the king is in check or not. So we need some sort of code to determine that, and that we will do in the next video. If you made it this far in the video, I thank you very much for watching this far. And if you'd like to check out my GitHub, please feel free. The link is in the description below. And hopefully you enjoyed this video and hopefully you learned something new. I hope to see you in another video next time. Thank you very much for watching. Bye.